Hey, what's up guys? I'm David Kopiniak and this is my advanced functions presentation on 7.6. So in this video, I'm going to be reminding you guys how to solve quadratic trigonometric equations. The question I chose to do was question 7b from page 436. The question says to solve for theta to the nearest hundredth where x is between 0 and 2 pi. The formula that we're given to solve is 2 sine squared theta is equal to 1 minus sine theta. In order to work with this equation, you must first set it equal to 0 and then factor it. So the first thing that you do is you move the 1 minus sine theta to the left side. So then you would get 2 sine squared theta plus sine theta minus 1 is equal to 0. Then you have to factor it. So you take the factors of 2 from the beginning of the question, which would be 2 and 1, and the factors of the 1 at the right side of the question, which would be 1 and 1, and then you multiply them across, so that'd be 2 and 1. But you need them to equal a positive 1 for the middle, so you would make the 1 a negative 1, and that way you would get 2 minus 1, which is equal to 1. So the factors of this would be 2 sine theta minus 1 and sine theta plus 1. Once you have the factors, you can set them equal to 0 and then solve them. So that would give you sine theta is equal to 1 over 2 and sine theta is equal to negative 1. Then you need to decide what quadrants to put it in. So since the one on the left is a positive number, then you put it in the quadrants that sine is positive. So that would be the all quadrant and the sine quadrant, the two top ones. On the right side, since sine theta is equal to a negative number, you need to put it in the quadrants where sine is negative, which would be the cosine quadrant and the tangent quadrant. To get the related acute angle, you need to move the sign over the equal sign, which makes it an inverse sign, like this. And for the right side, you need to make the negative 1 a positive 1, because in order to find a related acute angle, you need to have a positive in there. And we need to find the related acute angles in order to find the principal angles. Next, you just punch these numbers into your calculator and you will get theta is equal to 0.52 and theta is equal to 1.57. Once we have the related acute angles, the final step is to solve for the principal angles theta. So in order to do that, we look at the graphs that we drew before. So first, let's look at the one on the left side and the right triangle of that graph. So for that one, the axis that it's closest to is the 0 axis. So what we do is we take the 0 and we add the related acute angle, which is 0.52. And when we add them together, we get 0.52 radians. Next, let's look at the triangle on the left side. So the axis that it's the closest to is the pi axis. So we take the pi and we subtract the 0.52 since the triangle is before the pi axis. So when we calculate that, we get 2.62 radians. Now let's move to the graph on the right side of the screen and look at the right triangle. So the axis that it's the closest to is the 2 pi axis. So what do? We take 2 pi and we subtract the related acute angle, which is 1.57. When we calculate this, we get 4.71 radians. Now for the final triangle on the left side, we take the axes which it's the closest to, which is the pi axis, and this time we add 1.57 since it's farther than the pi axis. So when we calculate this, we get 4.71 radians again. So in this case, if there's two of the same answer, we only use one of them. So the ones in rectangles are the ones that will be your final answers. The reason why we got the same answer twice is because 1.57 is a half pi. So by subtracting a half pi from 2 pi or adding a half pi to pi, we'll get the exact same answer. And that's the end of my presentation. Hope you guys enjoyed and learned the question well. Bye for now.